Okay, what if we have a polynomial equation that isn't in factored form and it isn't in standard form? Well, then our process is first we get it in standard form, then we factor so it's in factored form, and then we use the zero property. Now, that's our general process. Get the equation in standard form, multiplying out if necessary, then factor, then use the zero property. If the equation is given to us in factored form, so a factored polynomial equals 0, we don't need to multiply it out and factor it again. However, if it's in the form a factored polynomial equals some number that is not 0, we do need to multiply it out. Why? Well, that zero property of multiplication is a very special property of 0. It's the case that if I multiply two numbers together and I get 0, one of those numbers has to have been 0. But in the example we're looking at here, right, we're multiplying two numbers together and we're getting 8. It's definitely not true that if I multiply two numbers and I get 8, one of the numbers must have been 8. For example, I can take 4 times 2. Neither one of those is 8. So if we have something factored equals a number that's not 0, we will need to multiply it out, get 0 on one side, and then factor again. And the factors we'll have in the end are going to be totally different from the factors we had in the beginning. So let's see how this works. First, we'll write our equation in standard form. So we've got x minus 3 times x minus 5 equals 8. We'll multiply that out. So x squared minus 5x minus 3x plus 15 equals 8. We'll combine like terms. X squared minus 8x plus 15 equals 8. And finally, we'll subtract 8 from both sides. So x squared minus 8x plus 7 equals 0. This is now in standard form. Once we have our equation in standard form, we'll factor the polynomial side. So this is a quadratic trinomial with leading coefficient 1. We can use the shortcut to the AC method, and we'll say our two numbers have product positive 7, sum negative 8. They have to both be negative. I think we want negative 7 times negative 1. Right. Negative 7 times negative 1 is positive 7. Negative 7 plus negative 1 is negative 8. Those are our factors. So we set each of those equal to 0. Either x minus 7 is 0 or x minus 1 is 0. In other words, either x is 7 or x is 1. Those are our two solutions. To check our work, we'll confirm that both of those work in the original equation exactly as it was given to us. So checking x equals 7, we'll have 7 minus 3 times 7 minus 5. So that'll be 4 times 2, which really does equal 8. For x equals 1, we'll have 1 minus 3 times 1 minus 5. So that'll be negative 2 times negative 4, which also really does equal 8. So plugging in either one of those values makes the equation true. Those really are the solutions to our original equation. Okay, one more. So here we have a polynomial equation that's not in factored form, but we have polynomials on both sides. So I'm copying this equation. On the left-hand side, I notice I don't have an x term. I'm leaving a little space there. And we'll see why in just a second. So I've got x to the third minus 4x plus 8 equals x to the third minus 5x squared plus 3x plus 6. Okay, so here's my equals sign. I'm just going to keep track of that. I want to get 0 on one side of this equation. And I'm going to choose to get 0 on the right side of this equation, just because I like to have 0 on the right-hand side. So I need to get rid of this x to the third term on the right. I need to subtract x to the third on the left as well. I'm going to get rid of the minus 5x squared on the right, so I'll add 5x squared. I need to add 5x squared on the left as well. I want to get rid of 3x on the right, so I'll subtract 3x. I need to subtract 3x on the left as well. And that's why I left that space, so I would have somewhere to write that minus 3x. And then I want to get rid of the 6. So I'll subtract 6 on the right. I have to subtract 6 on the left as well. So on the right, I have subtracted every term, or added the opposite of every term, as the case may be. So on the right side of this equation, I'll just have 0. On the left, oh, I've got x to the third minus x to the third again. That was lucky. Those canceled out. Negative 4x squared plus 5x squared, that's going to be plus 1x squared. Nothing minus 3x, that's going to be negative 3x. 8 minus 6, that's going to be 2. Okay, so I've got x squared minus 3x plus 2 equals 0. This is now in standard form. Now that I have standard form, I can factor the polynomial on the left. That's a quadratic trinomial with leading coefficient 1, so I can use my factoring shortcut. My AC is 2. My B is negative 3, which is negative 1 plus negative 2. Right, negative 1 times negative 2 is positive 2. My factors are going to be x minus 1 times x minus 2. Okay, I got standard form, I got factored form. One of my factors has to be 0. My factors are an x minus 1 and an x minus 2. Either the first factor is 0, which means x is 1, or the second factor is 0, which means x is 2. The solutions to my equation are x is 1 or x is 2. And I can confirm that that works in my original equation. Right, so when x is 1, my left-hand side is 1 to the third minus 4 times 1 squared plus 8. That's 1 minus 4 is negative 3 plus 8 is 5. On the right, I have 1 to the third minus 5 times 1 squared plus 3 times 1 plus 6. So 1 minus 5 is negative 4, plus 3 is negative 1, plus 6 is 5. So when I plug in x equals 1, I get the same number on both sides. When I plug in x equals 2, on the left, I'll have 2 to the third minus 4 times 2 squared plus 8. And I think that's a job for a calculator. On the left-hand side, I happen to get 0. On the right, I'll have 2 to the third minus 5 times 2 squared plus 3 times 2 plus 6, and that also works out to 0. So plugging in x equals 1, the two sides work out to the same value. Plugging in x equals 2, the two sides work out to the same value. Those really are, again, the solutions to our original equation.